Okay, welcome to the third lesson of the Algebraic Methods chapter. Today I just wanted to discuss a little bit about functions, graphing, equations, and inequalities. Whenever we have some kind of function, you should know what a function is. It's a kind of mapping. I'll talk about more what mappings versus functions are later, but let's just say we have a quadratic, so x squared plus 3x plus, or in fact, let's do x plus 2 times x plus 3, which gives us x squared plus 5x plus 6. Okay, so that's our function. And when I say a function is a kind of mapping, that means if we have our graph of x against y, we can essentially, map this function. So in this case, it will look something like this. And a mapping is kind of like if we put in a bunch of inputs, what are the outputs? So we get these like dots, and then it gives us this curve that looks like this. Okay, and then if we do infinitely many, we get this solid line, and it will look something like that. So that's what a function is. It's a kind of mapping, and we graph it like that. I'm sure you've seen this before at GCSE, very simple stuff. And an equation will be simple enough to solve. So we'll have this function, we'll have this equation that we equate it to 0, okay? It's equated to 0, and the mapping doesn't change. The sketch of this curve, if you will always forever remain looking like this. No matter what we do with this, no matter whether this is a equation, whether this is an inequality, this kind of base dot 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 pattern will always remain the same. But there's two things that each of these represent, and two things that they will essentially be asking from you whether they want an equation or an inequality. So an equation is asking us, where is the function equal to 0? That's what that's asking. I mean, it's quite obvious, it's equal to 0. We're asking, where is it equal to 0? This here, this x, is our 0 line. So essentially, when we have an equation, we're asking, at what point does this curve cross 0? Here we can see there's two distinct roots, we call them, where this crosses 0. And since we had the factorized form before, we know that this is minus 3 and this is minus 2. We know that, by the way, because once we had it like this, factorized, this equals 0, and essentially what we say is that this can equal 0 when one of two things are true. Either this whole thing is equal to 0, or this whole thing is equal to 0, because anything multiplied by 0 will simply be 0. So x plus 2 is 0 when x is minus 2, and x plus 3 is 0 when x is minus 3. Should be a minus. There we go. Okay. Another thing you need to note is that a quadratic is a kind of polynomial. Polynomials could be, x squared plus 3x plus 4, whatever. Could also be a cube. This is a kind of quadratic. Polynomials don't need to be quadratics. They could be x cubed plus 2x squared plus dot dot dot, which we call a cubic. They could also be quartic, which is x to the 4 plus dot dot dot, or quintic, or etc. etc. You get the point. It could be anything. And the thing you need to know about polynomials is that the largest power of the polynomial, for example, for a cubic, it's 3 here. For a quadratic, it's 2. The largest power is always the number of solutions of that polynomial. Always. This always is the case. It doesn't matter if you have a repeated root like this, x plus 1 squared. This is still a quadratic, but what this will look like is that we have x equals minus 1. That's true, and it will kind of look something like this, minus 1, and it will do that. Okay, so it seems as if it only crosses at one point, but we call this two solutions. It's essentially arriving at the line, we call that one solution, and then it's leaving the line. So x equals minus 1 twice. And this is something you always need to know, that the highest order of a polynomial is always the number of solutions. There are no exceptions. We could even have something that looks like this, where it doesn't cross at all, and we still have two solutions. In this case, there will be imaginary solutions, but we don't need to discuss that for now, so I'll leave that. Okay, so now inequalities. We can have, again, let's talk about the same function, the same kind of mapping. Remember, this f of x equals x squared plus 5x plus 6 always looks like this curve. It always does. There's no variation. And let's see, 2x plus 5 equals 0, x equals minus 5 on 2. So this here is minus 5 on 2. You don't need to worry about where I got that from for now. But, okay, we have two places where it crosses 0, but when it's an inequality, we can have two different things that it's asking us about. It could either be greater than or less than 0. And in this case, we need to identify very clearly what it's asking us. So when it's saying it's greater than 0, we're taking this function here, and we're asking at what point is this above the 0 line. And then you can, when we have it drawn out like this, you can quite clearly see there's anything between this point and this point here, and anything between this point and this point here will be greater than the 0 line. So in that case, x is, when this here is minus 3 and this here is minus 2, we can see that for it to be in one of these two areas, it has to be greater than minus 2 or less than minus 3. And that's our answer there. X is less than minus 3, x is greater than minus 2. Okay. The second thing they could ask you for is if the function is less than 0. So that's anything around this point. This curve here dips below the 0 line. So in that case, we can see it's anything on this side of the function. In other words, x is between minus 2 and minus 3. And a lot of people get tripped up about whether to have it as this or this, and because they're kind of guessing. I would recommend that you always sketch out this graph, and then it is painfully obvious whether x is between 2 points or x is less than a certain point and greater than a certain point.